And that was actually something that happened already back in 2016. I don't know if you remember, that was like the first time that people were talking in masses about DDoS attacks. But in 2016, there was a botnet called Mirai that performed an attack and that took down DNS, bringing down Netflix, Amazon, a whole lot of services in the US. And all of a sudden, people were like, oopsie, DNS can be a real problem here. So what Mirai did is actually also leveraging one of those protocols, DNS, one of the features of DNS, to turn it against the victim.
If, like you said, if someone downloads an AI, uses it locally, and that thing's poisoned, then an attacker could like send a special command or something and extract your personal data or something, right?
Oh yeah, AIs are the worst at keeping secrets.
Yeah.
Look at it like that. Never give your secrets to an AI. That's what Fraud GPT and Warden GPT did. Warden GPT started out, was a Portuguese student. They started out as a grey hat project, but it became so big that they then pulled the plug.
Hey everyone, it's David Bombal back with a very special guest. Pascal, welcome.
Hi David, thank you for having me.
It's great to have you on the show. Really excited about what we're going to talk about today. I've got a report in front of me, the Radware Global Network and Application Attack Trends Report, and then I've also got a 2025 Global Threat Analysis Report. Some very interesting stuff in here, and I believe you're the author of these reports, so I'll just throw you some stats that I read here, like web DDoS attacks up 549%, DNS floods like almost 100%, a whole bunch of other attacks, but you know this better than I. You wrote this. So tell us what's going on in the real world, because I saw you actually on LinkedIn posted just a few days ago at the time of this recording about X being DDoSed. And also there's this Dienet group, Hacktivist group, I believe. So perhaps you can take us on a journey about what this report is about and the sort of takeaways that people need to be aware of. Because I think a lot of people misunderstood or mistakenly believe that DDoS isn't such a big problem today. But based on the graphs that you got in this report and the stuff that I'm seeing here, it's like a major problem.
Remember when you were young and it was Christmas and you sit down, you put on your PlayStation, you want to play, and then it says PSN cannot log in, connection error.
Yep.
That's when you know that DDoS might be a problem, right? So, and it's of course, it's not limited to only PlayStation attacks. It's much more than that. And that's what we see happening now. And that's also what I covered in the report.
So Pascal, I've got these two reports. There's the threat analysis report, and then we've got this global network and application attack trends. Is it possible for people to download these, and where can we get them? I mean, if there's links, I'll put them below. Perhaps you can tell us, like, is it publicly available, and what's the difference between these two?
Yeah, so both reports are available. One of the reports is an executive summary. That's for the executive people who don't want the details and all the numbers and all the analysis that goes behind it. And then the other one, the full report, provides all the graphs and all the analysis of the data from our cloud. There's also several webinars that you can find if you go on Bright Talk and you look for Radware. You will find several webinars there as well, covering the topics of that report.
So for everyone who's watching, I've put links below to the two reports. I really enjoyed reading these. Pascal, you wrote these. Fantastic. It's great to see, real world examples of this stuff. And just for everyone who's watching, in this video, we discuss a lot of technical stuff. So this is not high level. We're going to go into the weeds. Pascal gives us a lot of really technical analysis of stuff. So make sure that you continue watching. I have to say this, shout out to Radware for sponsoring this video and making Pascal available. Hopefully we get you back, Pascal, for more detailed analysis of, cyber threats and what's actually going on. But without further ado, let's cut to the interview.
Now, to set the scope right, when we talk about a global report, we talk about the global scope. So that means worldwide report. But what we are looking at and what we are zooming into is network and application threats. And when I say network and application threat, I'm not talking about the local area network. So I'm not the inside network that you have in your house or in your company, but actually the internet. So the threats that we will talk about, like DDoS attacks, are the threats that are happening on the public internet. An internet that was created as a best effort network, created with all the best intents, open for everyone. But for some reason, businesses found it a good idea to run multi-billion-dollar businesses on top of that best effort network. And that's where the problem for DDoS starts. Everybody can access that network. So that means whatever you put out there, you put it in the public. It's like putting it in your front door and then thinking that nobody will pick up your package if it's out in your front door for like 2 or 3 weeks. So you have many drive-bys, cars that drive by that throw stuff in your garden, all kinds of nasty stuff. Those are the DDoS attacks. People who are trying to do exploits in your online applications. And it's gotten worse since COVID. So in the report, I also talk about the threat landscape revolution. I used to talk about the threat landscape evolution.
Okay.
But if I look at the last 3 years, and I've been in the industry, I'm a bit older. So I've been in the industry for about 25 years now and always been in security. So I saw things being connected. I even had the time with the dial-up modems where nobody cared about security. And then all of a sudden from dial-up, you come to broadband. And then your IP address, it's always connected. So now you need to have a firewall. And then if you look at nowadays, if you think that an IP address is as good as a password, forget it, because everybody can scan the internet in like less than 1 hour.
Yeah, Shodan, right?
That we have. So it's very important for organizations, and especially since COVID, many organizations moved to the public cloud because they had to allow people to work from home. So moving an application into the public cloud was the best solution to allow people working from home. So we saw a big acceleration in the number of applications. Also, if you look at most of the companies, and I'm sure this also goes for many of the people that are listening and also for you, David, but you're not using a single public cloud.
Yeah.
You're using 2 or 3 or 4 of them. And if you ever went to look into what kind of settings that you have in terms of permissions and metadata and all the security controls and the different logging, it's different for every cloud. So it becomes very difficult to control that. So what we are saying is that organizations face a problem where their attack surface is expanding. So you have that major attack surface, and then on the other side, you have the bad guys who want to profit from this.
Yeah.
And one of the bad guys that you were zooming in on was now the attackers that were trying to attack X. So with the attacks on X, it was a DDoS attack, that is for sure. And that was also confirmed by Elon. But the only one that we saw that claimed the attack, and it corresponds when you go check on Down Detector, where there's typically Down Detector keeps track of all the different complaints that are coming in from people who cannot connect. When you see it ramp up, we had a claim coming out on Telegram by a threat actor, a hacktivist threat group that is called Dark Storm Team. So in Dark Storm Team, it's a group that we were tracking already from before. They already did attacks, mostly politically driven. So attacks, and that is a pro-Palestinian group. So we see a lot of attacks from Dark Storm Team Israel, for example, because they are pro-Palestinian, so they want to let themselves be heard. Now, what is typically the motivation of a hacktivist? The hacktivist is the same as an activist in the street. Why are people walking in the street and blocking the street, sitting on a crossroad to block the cars? It's to get attention. They want to bring out their message. A hacktivist is exactly the same, but in cyber. And their road is the internet highway. So what they're doing is they perform attack. They try to cause disruption. They try to cause chaos. And by doing so, get the attention of the media. And then in their message, whenever they claim the attack, and typically they will claim it on social media, and one of the biggest platforms for claiming is Telegram, they will claim it on Telegram, and they will also put in their typically politically driven or ideologically driven message. So in this case, it was Dark Storm Team. Now it gets a little bit more complex because many of those hacktivists, and we saw them ramp up in 2022 when the conflict in Ukraine started, especially from the pro-Russian side, but also from the Ukrainian side. So the IT army of Ukraine, for example, that was created by Mikhail Fedorov, who was the vice president of Ukraine, the vice president for digitalization at the time, created the IT army. And for the first time that we saw this happen, he went out to social media and he called for the rest of the world, for everybody who is positive and who wants to support Ukraine, to start performing DDoS attacks with the IT army of Ukraine. So he created a Telegram channel. He posted hosts that should be attacked. And then they started creating tools to help people. People could download those tools. And you saw even people in the US, especially young people, who were bragging in the press about, I attacked those targets in Russia and I was helping Ukraine. But of course, you will have a counter movement from the other sides, which was the pro-Russian hacktivists. So that's in 2022, that's where it all started. And that's where Telegram actually came on the scene as a major hub for underground activity. And when I say underground, I would say probably the underground above ground. So the criminal activity that is happening on the public internet and easily accessible on Telegram. Anyone with a Telegram account can find those channels and can follow what these hacktivists are doing and who they are attacking. So in the case of X, it was Dark Storm team that did the attack. They claimed it. And there are two possibilities here, because Dark Storm team is also a provider of DDoS for hire services. So many of these hacktivists, they need resources to attack. If you want to do a DDoS attack, especially against a large company like X, you need a lot of bandwidth, you need lots of resources to pull it off, to cause a dent in their activity. So in this case, you would see that Dark Storm team is also offering DDoS for hire services. And that can be as easy as going on WhatsApp and sending, or on Telegram and sending a message to the owner, paying a subscription of like $20, maybe $30. And then for one day, you can attack hosts. So you just tell him, oh, I want to attack this host. And then the attack will start on that host. Some of them are automated. So I don't know how far you know Telegram, but Telegram provides much more than just messaging and public soundboards or channels where you can reach a large number of subscribers and members. But Telegram also provides services like Telegram bots. It's very easy to write a Python bot that integrates with Telegram. And whenever there's an instruction given in the Telegram channel, the bot will execute that command. So before we saw DDoS for hire services, or we also call them booter and stressor services for the people who heard about booters and stressors. So those DDoS for hire services used to be web panels, but now you can also build them in Telegram. Now, Telegram also provides another feature, which is payment services with crypto. So you have like a full stack now that comes close to a WeChat app. So WeChat has all those apps, and they also have games. So Telegram is still missing the games. But if you look at what we have in Telegram now, you have a full stack where you can implement a service. It can be a legal service, but also a criminal service like DDoS for hire. So Dark Storm team is providing such kind of services. So there's two possibilities for the attacker on X. Either it is somebody who commissioned the attack and Dark Storm team leverage the moment to make an advertisement, or it was Dark Storm team itself. So what we see from a lot of those providers of underground services is they need advertisement. They need to show that their product is good, right? What's the best way of showing it? Bring down a company, an organization, attack an organization. But if you attack the pharmacy around the corner here in whatever state or street, nobody will notice, nobody will be interested. But if you bring down a company like X or Tesla or SpaceX, so you go after the big names. And that's another possibility, that it was purely for the advertisement. But mostly for sure, all the things align. Of course, attribution always very hard. We can never say 100%. And even if they claim it, because remember, those are criminals. If I have one piece of advice, it would be never trust criminals. Yeah. So when they say it was me, well, you also have criminals out there that are looking at Down Detector, because you can go to the website of Down Detector right now and look which one is down. Okay, and now I quickly going to post a claim that it was me. Now, they have some ways of providing proof, like typically what those activists are doing, and also something that we are using for tracking them and for keeping track who is attacking who and why they are attacking, is checkhost.net. So that's a website, checkhost.net, where you can go to this website. It's safe to go there. So if you want to go there with a browser, go there. And then you can put in whatever website that you want to test. And Checkhost has probes around the globe that are trying to connect to that website. And if the website is available, it will show you that it's available and that it has success. So lots of those hacktivists, and that started already early on in February 2022, when they started doing attacks on European targets for political reasons. They always post a check host, and the check host shows you that at the moment that they checked, so it's like a persistent link to a report in the past that shows that those websites were unavailable, that they were not accessible. So that's kind of giving a proof that they were attacking. Circling back to Dienet, the second part of your question, Dienet is also one of those hacktivists. So, and Dienet is very recent, because the first that I saw them was early March, so earlier this month. The first 2 weeks they were attacking Israel. They went also after what other countries? A couple of other countries. Netherlands was one of them. All political messaging. Then they got banned because after Durov, the CEO of Telegram, got arrested in France because he was too lenient towards criminals leveraging his platform. So they asked him to be more transparent. Since then, we see that much more of the Telegram channels are being banned. For example, if you live in the European Union, you will see that some of those pro-Palestinian activist websites are banned because of propaganda. And what we see now happening in the last month, it has been much more accelerating. It's like a play of whack-a-mole between the authorities and hacktivist channels.
Yeah.
So you have the hacktivist like Dienet who has his channel. They do an attack. They claim the attack. And then the authorities, they ask Telegram to ban the account. Sometimes it can be Telegram or the authorities. Sometimes can also be competing hacktivists, because competing hacktivists want to be in the spotlight. So that's competition for them. So they might also file reports and ask their members, because they have many subscribers, ask them to do an attack on that channel to ban it, to file reports for banning and for unusual conduct. So they can also be banned by competing hacktivists. So, but when an channel is banned, so it was called like @Dienet, but then they came back with with Dienet, but the I with the 1 now. And you see the same for thread groups like NoName 05716, for example, who's the most active and the most popular pro-Russian one. They have been banned for several times already. They always come back with a backup channel or a reborn or channel 2. In the case of NoName, they now even have a NoName Italian, NoName French, NoName Spanish. So they have all kinds of different channels where they keep the backup. So it's purely a game of whack-a-mole. Whenever you take one out, there's like 3 or 4 coming back up. So Dienet came back and then started attacking the US, many organizations in the US, in the financial and also government, and also a lot of attacks targeting Trump websites, clearly, and also the messaging on their channel was clearly against Trump. So they were not really good friends with Trump. And a little bit in the same context, I think that Dark Storm team, or the one who commissioned the attack through Dark Storm team, was opposed to Elon Musk.
So you mentioned application and network, and I've read in the report here, one of the applications was HTTP2. So perhaps you can explain why that's a big problem, because, I mean, go technical, please, because I'd like to know, like, how are they doing these attacks? Like, what are the applications? What are the protocols? And what devices are they using? I'm assuming it's IoT devices, but is it other devices, etc.? So again, like, let's go deep. Tell us, how's it happening? Network attacks versus, I'm assuming that's maybe DNS, but like what are the attacks that are happening, and protocols, and then like the devices actually being used to launch these DDoS attacks?
So if you look nowadays, when you want to target an application or you want to target a company, you want to target its website.
Yeah.
That website is hosted in the cloud.
Yeah.
That cloud typically has lots of bandwidth. If you want to bring down that application, you need to throw maybe 1, 2, or 3 or multiple terabits per second of traffic at that cloud. And you're not going to bring down that single application. You're going to bring down the whole cloud, basically. Yeah. How can you target that single application? That's by going after the application. So what we saw is that DDoS actors, where they used to use attacks that were layer 3, layer 4 based, so network based attacks, where they used volume.
Like TCP, SYN and stuff like that, sorry.
You have the SYN attacks on one end, which is resource exhaustion. So if you have a firewall, for example, that keeps sessions, you would do a SYN attack, and then the firewall would allocate sessions and you would be exhausted of resources. Yep. Or a low and slow attack against a web browser, where you create an HTTP connection and you do a file download, but you only allow it to download at 1 byte per 10 minutes. And you make like thousands and thousands of connections. That's slow loris, for example. So those were the kind of attacks that you saw before. And the bandwidth that you had before, people were hosting their web services on-prem, which means that the bandwidth that they had was typically less than 1 gigabit per second. So if you could throw more than 1 gigabit per second, and that was fairly easy done, especially when you use amplification attacks, leveraging DNS servers or NTP servers, then you can easily get to that threshold and you can saturate the line so that no communications are possible. So that's to bring offline that website. I already just mentioned amplification attacks, and that might ask some questions because I was just throwing it out there with DNS and NTP. How does that work? So if you have a DNS server, typically what you're going to do is you're going to do a DNS query to the server. So when you are sitting at home and you type in davidbombal.com, for example, or co.uk, I don't know what it is.
Yeah, .com, yeah, that's fine.
So when you type in davidbombal.com, you don't know the IP address. So it will go to your ISP's DNS server, who will then try to find the authoritative server, DNS server for the domain, ask to translate it, get the IP address, and give it back to you. Now, once you have the IP address, you can serve to that domain. Now, that's a simple query. It's in UDP, can also be in TCP. It doesn't take a lot of, so the answer is small. But you can also do a DNS query where you say query type any, for example, where you get a whole list of the whole domain, all the names. Now, what you see is that with a small UDP packet, with the single UDP packet with a query, I get a stream of UDP packets back to me.
Yep.
So, and since it's using UDP, that means that there's no connection state. So that means I don't need to connect from my PC to the DNS server and then get the acknowledgement and set up a session. No, I just sent a UDP. Yep. The DNS server gets it. What does the DNS server do? Who asked this question? Well, that's the source IP. So I just switch source and target IP, the source and destination IP, and I reply.
Yep.
Now, if I send a request for Q any and I spoof the source IP, so I change the source IP from my IP to somebody I want to attack, the IP of somebody else, then I will send it to the server and the server will respond to that somebody else.
Yep.
And that is a big problem in DNS. And unfortunately, it's something that we cannot solve. Yeah, there's DNSSEC, but as you know, not everybody supports it yet. And yeah, it's not that easy. So there's always servers out there that exist and that will allow such kind of behavior. And taking out DNS is not a solution, it's the cornerstone of the whole internet. So if you take out DNS, it all crumbles down. There's more problems with DNS, like, for example, a DNS DDoS attack, a query flood attack. We also saw that coming up a lot lately in the last 2 years. And that was actually something that happened already back in 2016. I don't know if you remember, that was like the first time that people were talking in masses about DDoS attacks. But in 2016, there was a botnet called Mirai that performed an attack and that took down DNS, bringing down Netflix, Amazon, a whole lot of services in the US. And all of a sudden, people were like, oopsie, DNS can be a real problem here. So what Mirai did is actually also leveraging one of those protocols, DNS, one of the features of DNS, to turn it against the victim. So what they wanted to do, the goal of Mirai and this threat actor that was leveraging that Mirai botnet, which was also a DDoS as a service, by the way. It was DDoS for hire. So it was somebody who hired that botnet to perform the attack, is to bring down a certain domain. So let's say you want to bring down davidbombal.com.
Please
what
don't.
I'm going to do... Not tonight, please.
Not tonight,
So what they typically would do is they will use many IoT devices. So IoT devices are like routers that sit at home that we use for our day-to-day internet connections that are getting exploited. Why are those devices getting exploited? Well, many of those modems have default passwords. You might say, well, hey, those people should put in a secure password. But yeah, do not forget that most of those routers are mom and pop's routers. And once the Wi-Fi works, you don't touch it anymore, right? So don't expect those people to do firmware upgrades, especially if we, as specialists, and David, you probably also know that whenever you do a firmware upgrade, it's like, is my device going to come back? It's like almost praying, sitting on your knees, waiting for that device to come up. Does it fail or not? So you can imagine that many of the people who have routers at home, Wi-Fi routers, will not perform firmware updates. And there's many vulnerabilities in those devices because price is one of the things that is important in those devices. If you can buy it for $50, come on, what do you expect? There cannot be that much research and security put in that device. So that was a big problem at the time. So many of those devices were allocated in botnets. And we're talking several thousands. In the beginning, we had botnets like a guy called Daniel K., also known as Spider-Man. He assembled a botnet of more than 900,000 of those IoT bots. And he performed an attack on a competitor of a mobile operator in Liberia. And while doing the attack, he just brought down all of Liberia. Wow. Oopsie. That's where actually the authorities went after him and discovered him. So back to my story. So those IoT devices, so typically I already explained how you do a DNS, name to IP address. Now, there's an ISP server in between there. So you send the query for davidbombal.com. He will try to find the authoritative DNS server and send it forward to that authoritative DNS server, gets the answer, sends the answer back to you. If I ask it again, if I ask, for example, www.davidbombal.com, then he will cache that information. So now the ISP server will directly answer me. He will not go to the authoritative server anymore. There's DNS cache. Now imagine a botnet of thousands of IoT devices all doing queries at something random.davidbombal.com. And the random part is very important. That's what we call the water torture attack. So that random, you just send it through, you send it to the ISP server, he looks in his cache. It's not cached because it's a random name, so it goes to the authoritative DNS server. The authoritative DNS server gets so many requests that he slows down. What does the ISP server do? Well, retry, because it takes too long. So he increases the flood back onto that authoritative DNS server. And the authoritative DNS server, one of the mechanisms that we have to make sure that it's not a person that is attacking us or a script that is attacking us is doing challenges. Now you're doing a challenge against an ISP's DNS server. Well, it's a real server, so the challenge will come back positive saying, yeah, it's a real DNS server. So that's what actually brought down the whole of Dyn DNS, and that impacted so many other services because those services depended on Dyn DNS to resolve their host name. Yep. And if you bring down DNS, there's no way to access the websites anymore. And that's an attack that we still see as of this day. And we had a very big increase. It's also in the report in last year and the year before. Now, circling back to HTTP2, and I already gave you an example of how the protocol like DNS can be abused for amplification attack on one side, query floods on the other side. When you look at HTTP2, there was at some point, it was end of 2023. Yeah, I'm correct. Last year was 2024. So the year before, in October, there was a report that came out that attacks were discovered in the wild that were using what they called rapid reset. And rapid reset, if you look at our internet, when you're loading a web page, you do a web request, you get many components for that web page. You get one frame, you get text, you get images. Now, if you serialize all these requests, so if first you would download the text and then you download the image and then the next image and then the next image, that takes a long time, right? So what HTTP2 started to do is allow concurrent sessions. So it already was in HTTP 1.1. That was called pipelining, but pipelining had a problem with head of line blocking. So that means if the first one was too slow, well, the other ones were also slowed down. But they solved that problem in HTTP2 by using concurrent sessions. So you have to look at your HTTP2 connection as like a tunnel where you can create sub-connections to download all the resources from the website. Now, to make sure that it's not abused, only 1,000 are allowed. Now, one of those attackers found out that you can start 1,000 sessions, and before you get to the 1,000, you reset the first one. So a new slot comes open.
Interesting.
However, the server is already processing the request. So even though HTTP2 knows that this session is reset, that HTTP2 is a sub-process in the web server, and he was already fetching the page and coming back with the answer. And then he will see, oh yeah, you didn't need it anymore. Okay, whatever. I just drop it. But at the same time, the server is busy. So he found a way to just leverage that HTTP2 and make many, many, many new connections. So sub-connections inside that HTTP2 to a web server. And one of the things to bring down, and that was the point that I say, when you want to go after an application in the cloud, how do you target that specific application from that company? Well, you go application level. How do you go application level? That's by doing HTTP queries. Do many, many, many queries. And actually, Anonymous, many years ago, at the start when Anonymous came out and did DDoS attacks, how did they do DDoS attack? They was asking their members, because they had a very big community, hey, go to your browser and click refresh over and over and over again. And if you have enough people doing that, the website would go down.
Interesting. Yep.
So that is a very manual way of doing that. Nowadays, they do it with a botnet that is leveraging many bots around the world and who is bringing that down. Another thing that we saw last year in threat actors, because keeping track of botnets is very difficult. So whenever you have a botnet, and there's lots of competition also out there. If you have an IoT botnet, whenever you reboot an IoT device, typically those bots are not persistent. When you reboot your device, the bot is typically gone. But then, and I did some studies on that back in 2018, whenever it comes up again, on average, within 2 minutes, it will be taken by another botnet, because there's so many out there that are trying to take your device and leverage your device for other things. So it could be that as a bot herder or a provider as DDoS for hire services, that you lose your botnets for some reason, like an ISP does a mass reboot of all the modems across his network, and all of a sudden you lose like 70% of your botnet capability. That's bad for customers, because customers want to do attacks, and all of a sudden you have no capacity to run it. So your attacks are not doing anything anymore. So many of them started to move back to cloud servers again, and centrally managing cloud server. We have Terraform, we have all the tools, all the good stuff that DevOps did to create and manage multiple nodes and to scale that. What they use now is scripts that are running on central servers, and those scripts do HTTP requests. So as many HTTP requests as possible. And what they do to make sure that, because if you are being attacked and you get like 100,000 HTTP requests per second from one IP address, what you do, I'm going to block the IP address, put it in my router. So hardware level, not a problem anymore, except for the bandwidth. But the bandwidth is only small because those are just requests. So it's not a volumetric attack. The idea is to actually make sure that the server is using too much CPU. So you can have those attacks coming in at the HTTP2 level, all these requests, and it comes from the same IP. Well, that's too easy. So what they found is there's many proxy providers around the world where you can rent like 100,000 proxies. And those proxies, most of them, again, run on IoT devices that were compromised and illegal. So, but instead of now being the bot that initiates the attack, they are just a proxy. So for every request that server is generating, he's switching to another proxy. And even though it's a single server that is generating the attack traffic, as a victim, what you see is 100,000 servers that are coming at you and that are attacking you. And then it becomes very difficult to block, because some of those, and that's what we saw happening with No Name 05716, a pro-Russian hacktivist. What they did is they did recon. And typically when you have DDoS attacks, not a lot of people do recon before a DDoS attack. What they do is they try to find the origin IP if it's behind caching servers. But besides that, there's not much recon being done. No Name, however, went to all the applications that they attack, and they look at the application and they look which web pages would use backend infrastructure. For example, a search. If you have a search on your web page, when you put in a search term, that takes a lot of resources in the backend. If you have a post form, like governments have many post forms that are open to the public to provide feedback. What they found was that using that, crafting posts and leveraging the real variables of the website, but putting junk inside them. So randomizing. But they even had specific randomizers. So for example, when it's a phone number, they would randomize a 10-digit. If it's an email address, they would put in a random email address. If it's text, they would put in random text. So now those websites are getting hit with thousands of requests per second, but they all look legitimate. It's only the data that is trash. But if you know how a web application firewall works, a web application firewall will be able to learn an application and can test for every variable that you have out there that the right variables are submitted, and can also test if, for example, if you ask for a phone number, that it's only digits. So it will test for that. If it's not, it will block it as an illegal connection. However, in this case, it's junk in it. But yeah, WAF doesn't know that this is junk.
Yep.
Because it falls within the confines of the application. So they didn't find anything better than doing attacks like that. And using that, they didn't need a lot of volunteers even, because their attacks were limited in number of requests per second. If we look at like attacks that have been seen in the past, web-based or web DDoS attacks can go up to 70, 80 million or even 100 million and above requests per second. So that's a whole lot of... They had enough with 100,000, maybe 10,000 requests per second to bring down the same website, because they were targeting the backend. Wow. Imagine that you get 1,000 requests for a search in your database.
Yep.
Well, your database is going to go down, going to fall over pretty fast, unless it's a really highly distributed and then lots of resources. So that's where the HTTP2 is in connections per second and requests per second to keep that server busy. That's the most important metric. Now, HTTP2 gives the attacker the ability, so they can already generate like thousands of requests per second. But if you write a Go program and you have to each time make that TCP connection and then do that negotiation, then do the TLS negotiation, TLS three-way handshake. Once that is done, then you can submit the request. And that's only for one request. So you have to redo that thing over and over and over and over again. So it takes a lot of resources. Now with HTTP2, you do the TCP handshake, you do the TLS handshake, you have your tunnel in HTTP2, and now you put your requests in. Very fast and lightweight. So all of a sudden, they gain a lot of requests per second because they found a way to make it much lighter for them.
It's amazing. I mean, I love the stories. I wanted to ask you, you spoke about like home routers. There's this protocol, is it TR69 or something, that ISPs use to
TR069,
to manage the routers. That's also a problem, right? Because ISPs get compromised or that protocol can be used to use home routers as botnets. Is that correct?
Exactly. That is actually the protocol that for the first time has been abused. And that's where I learned the protocol by Daniel K. Remember that I talked about Daniel K, aka Spider-Man?
Yep.
He found that a lot of service providers leveraged TR069, and there was a command execution possibility by just sending an XML request in, and TR069 is just TCP with XML. So all you have is SOAP and XML. So it's a SOAP envelope that you sent as a request to a modem to reconfigure it. And he found out that there was a way to reconfigure it to put in a remote command execution. And that's what typically botnets are after. If they can do remote command execution, what you will see in that remote command execution is a wget or a curl towards a certain website and binary. And then they download the binary and they execute it. And those IoT botnets are very stupid because they don't even try to understand the platform that is there. They have like 6 different binaries. One is for ARM. The other one is for x86. The other one is for 64-bit, one for 32-bit. They have all the different binaries, ELF binaries for Linux, and they test them all. And the right one will run and the wrong one will fail with a core dump. So they just try them all, just try to run them. So all they need is remote command execution to infect a device. So, and that is exactly what happened with that TR069. In that XML, there was a command where you could put a remote command execution, and he was able to download his botnets onto that. And back in 2016, he leveraged that attack against Deutsche Telekom and tried to compromise 900,000 modems. Now, luckily, it failed. It failed because the modems, for some reason, they rebooted upon this command that he put in. So, but overnight, 900,000 modems were rebooted and lost internet connection. So Deutsche Telekom had an issue, but it could have been much worse because that guy already was sitting on almost 1 million bots, and he probably was going to add 900,000 more. Post Office UK is another one that was affected by those attacks. And TR069 is a protocol that came back over and over and over again in IoT botnets. That is correct.
It's amazing because we've done videos before on the channel where we talk about not using your ISP router because it sounds like it's a cheap device. It's not hardened. Rather put your own firewall in. I see you're nodding your head. You agree with that?
Mostly. It depends on the person. If it's a person like you, I would say, yes, do it. If it's somebody else, no.
Like my mother, yep.
Because even the small, and they got better. So let's be honest, this problem that I'm talking about, this TR069, that's from 2016. So it's a while ago. Many of the issues were already fixed. I'm not saying that is better. It's like it comes in waves. It's like AI. It goes up and down. You have winters and you have summers. The same with IoT devices. I tracked many IoT botnets and bots and threat actors back in 2016, 17, 18, and then it slowed down. But now it's coming back up. Now we see it back as a problem because we see more often botnets being leveraged in attacks again. And also for those proxies.
I've got to ask you this question, though, because you said, so I think I've heard you say previously, and I might have read it in the report, that attackers stopped using IoT devices because, like you mentioned now, if they reboot it goes back to factory defaults and someone else could load, their malware on it or whatever. But they started using cloud-based services. And then the question is always, but if you register on AWS, then it's easy to find you.
Well, you also have, that's on the public cloud. Now, you also have bulletproof cloud services.
You got to explain that.
Bulletproof cloud services like underground cloud providers. So if you go to that cloud provider, and typically there was a couple of years, like 2 years ago, I think, the Bunker it was called. That was a data center that was in an old World War bunker, hosted in an old World War bunker. And that was in the Netherlands, close to the border with Germany. So and there they were hosting servers, and those servers, whenever there is a cease and desist from the authorities, or if you would do a legal email or ask them file for abuse, for example, they just ignore it. So, and there sit all those servers that run the underground. So like porn, illegal porn servers, phishing servers, malware services, and also those attack servers. So you just search for bulletproof services, you might find them. This case was in the Netherlands, and it was underground because it was illegal. But you also have things like Iceland, Gibraltar. Those are areas where there are different kind of laws and regulations that are much more lenient for such cyber services. So typically they would be, Panama is another one where you would see some of those things. Typically where you have lots of gaming and betting servers, you might also see those underground bulletproof cloud services. And you can send as many abuse emails, because that's typically what happens. When you send an abuse email, then the cloud provider looks into it, looks at the traffic log, says, oh yeah, he's right, that's illegal. And then if it's really a real big crime, then the authorities might ask for more information and then follow the money, and through credit card statements, typically they will find out who was behind it and be able to apprehend them. But typically it's just an abuse email and then you take down the server. But in this case, it doesn't help because they are running them in what we call bulletproof servers.
So that's interesting. So the sort of attackers have moved to using cloud-based services like that, and they launch huge traffic from that. They can spin them up very easily, launch these huge attacks, but to mask the fact that it's coming from, say, a single IP or range of IPs, the traffic goes through proxy servers on IoT devices or other devices. Did I understand that right?
Exactly, yeah. And that makes it easier to scale their operation, makes it easier to manage their operation. Before they had to manage tens of thousands of IoT bots. And there's lots of competition, so lots of fragmentation. Now with those proxies, there are free proxy lists where you can easily, I'm not saying that you're going to find 10,000 free proxies, but free illegal proxies, it's easy to find in several hundreds of them on free lists. You just go to GitHub, to some of the gists that are not published. You can download the whole list and then you test them, and whatever works, you can use it. And it's easy to get like 500 of them, assemble them, and then leverage them to perform attacks. If you want to get more, then you can go to commercial services. Commercial services have already created those proxies, and some of them are legal. So actually there are some legal proxies to provide anonymity. Just like the same way with Tor. Tor, for example, was created to be anonymous. It was not created as an underground conduit, right? It was created for journalists to be able to submit information and talk with other people, have chats without compromising their identity or compromising their location. But Tor, because of that anonymity, was being leveraged then by criminals for other things, right? So, and the same goes with those proxy services. So some proxy services can be a big Ubuntu server running Squid proxy, for example, and just renting or leasing a full residential IP range from the ISP. And they can switch IPs between that ISP range. Now, the most important for those proxies is to have residential IPs. Because if you look at bot management, bot protection, whenever you get connections coming into a website and want to be sure that it's a human, the first thing you're going to do is going to test, does it come from a data center? Does it come from Amazon.com? Okay, that's not a human.
Yep.
Most probably not. So residential IPs are very important. Also for bots who do price aggregation, because bots, we don't talk about bot protection. We talk about bot management, because you need to manage the bots. It's different like DDoS attacks. A DDoS attack, you want to block it, right? You don't want to manage it. It's block it and keep it out. However, if it's bots, you need to manage them because you have good bots and bad bots. The good bots might be price aggregators, for example. If you want a flight, you go to a price aggregator, you ask for a price, and they will get all the information. Can be done by APIs, but sometimes it's also bots that are scraping information from the internet. So like mostly when you want to buy a keyboard and you go to one of those price comparisons websites, typically they go scraping for that information. Now, those are good bots because they can enable your business. You want to let them in. You also want to let in Google. Google also comes crawling your website with a bot. But do you want to block Google? No, because you're probably paying your marketing officer might be paying thousands of dollars per month for SEO optimization and to get higher in Google, and you're going to block it. No, it's not a good idea. Now, bad bots also exist because they come and scrape your content and they might leverage your content. So that's where we talk about bot management. And then it's important for those bots to leverage residential IPs. And that's where we see a lot of those bots also being leveraged for those IPs.
So the devices that are getting used in the botnet, is it like we've mentioned, like home routers or modems? Is it other types of devices as well? I'm assuming it's like cameras and stuff like that.
Oh yeah. So anything that is insecure and on the internet, IP cameras is Unfortunately, there's many IP cameras that are out there building security services, quote unquote, that put an IP camera on a apartment that they are responsible of, and they put that IP camera directly on the public side of the Wi-Fi, thinking that, well, it only has an IP address. Nobody will ever find it, right?
Yeah, right.
And username, password. Well, no. It says, whoever gonna guess that my password is password or password 123. Well, maybe nobody's gonna guess it, but anyone has access to the manual. Anyone can Google what is the default password of whatever camera vendor. You will find it. So cameras, but also later on, Linux servers, because those IoT devices, while good, they are typically limited in their capabilities. They have limited CPU, limited memory. Imagine that was also the time where we had Docker coming up. And many Docker images out there on the internet, and also VMware images out there on the internet that you can download. Now, many of those VMware images have a default password or have secure shell enabled with root without password. And of course, they tell you to change the password, but that's somewhere in the manual. Now, who reads the manual? Come on.
Exactly.
You download the VM, you run the VM, and then you go whatever. Oh, it works. Yeah, great. Next project. Very efficient. But yeah, at the same time, you have a VM running in the cloud with SSH enabled and root open. So they started leveraging the same kind of botnets that did SSH and tried username password to just get into Linux servers. First, that was by accident. And then after they saw that, oh yeah, hey, there is a good opportunity here. We can go after servers. And then they found even bigger ones, which were Hadoop clusters. There is a protocol. I forgot what the name of the protocol was, but there is a way through XML, and I guess XML now, to submit a task for the cluster to execute. Now, many universities had Hadoop running and put in on the internet so that students from home could submit tasks for their big Hadoop cluster. But there was no security by default in Hadoop, so you should have put a proxy in front of it with authentication, but they didn't do that. Some attackers found out that, hey, there's some really big performant clusters out there where we can run commands. All we have to do is just submit an XML and try to get it in. Now, how do we know all that? Because we're running honeypots. So I have honeypots running in the cloud, and even at my home, I have a honeypot, and that's listening on all the ports. And whatever command comes in, I try to grab it. I try to talk with them. So it's not like a Linux device that I let them do anything and I monitor, because that's too dangerous. You don't want to do that, because they might jump. Even if you think that you're well isolated, there's always a way that they might jump laterally. So I just have a conversation with them. So I accept the incoming connection, I converse with them, and I try to trick them into giving me the download location of the malware. And once you have the download location, then you can download it, you can reverse it, you can find out what attack vectors they have. Is it for DDoS? Is it for another case? Is it for account takeover attacks? And there you can find all the information. Now, when they do these Hadoop attacks, of course, at home, I'm not running a Hadoop server.
Yeah.
But they don't care. They just scan the whole internet range. Now, they can be more precise. So they know that if they scan the whole internet range, they're going to trip over a couple of thousands of honeypots from security research in only a matter of time before their command and control is taken down and they lose everything. So they got smarter. They leveraged services like Shodan, Gray Noise. And Shodan, for example, I don't know if you know Shodan, but Shodan is we call it an IoT search engine. It searches more than IoT. But what Shodan done is scanning the whole internet IP range. And then it will do a port scan. And whenever it finds a port, like, for example, port 22 is open, it will connect, and then it will scrape the banner, keep that in a database. Whenever there's a web server open, it will scrape the web server, keep it in a database. So now when I go to Shodan and I say, show me all the Apache servers with that version, Shodan will give you a list of all the IPs.
Yep.
To make things worse, now Shodan also provides you with CVEs.
Yep.
You want to attack a certain CVE, you just put in the CVE, you get all the IP addresses where Shodan found this CVE to be open and to be vulnerable. So now they can go much more targeted than before. Before they had to scan the whole thing and then they tripped up the honeypots. But they're still tripping up. I still see a lot of attacks coming into my house, a couple of thousands per day.
I've heard you say that attackers were getting people to download stuff onto Android phones and devices to also launch attacks. Is that right?
Yeah, of course, it happens with, well, there are some set-top boxes for TVs, for example. And I don't know if you ever owned a set-top box and you were running one of those Plex clone services that are free. One of those services, I'm not going to give the name, but one of those services, when you go in their manual, it's open source. When you go in their manual, you will read that to be able to install it, you need to enable debug mode. Otherwise, you cannot sideload it. It never tells you to disable debug mode. Now, when you enable debug mode, you're also enabling ADB, the Android debugger, which is a port that opens, port 99,000 something. I forgot it. So that ADB protocol can now be used. And if you scan for the ADB protocol, you will find some set-top boxes that are explicitly open. And there were even botnets that were scanning the LAN for those set-top boxes to infect those boxes as well. So that is one way. The other way, phishing and so on is less of a tactic from IoT botnets. So when I talk IoT botnets, you have to imagine those are very unsophisticated malwares written for Linux. They do zero evasion. Why? Because who's running an antivirus on his IP camera or on his router?
Yeah.
Even today, we're not doing it, right? So there's no need for evasion. There's nobody who looks at the device. When you sit behind your computer and you're infected with a malware and you get a pop-up, oh, that's strange. I had a pop-up.
Yeah.
Hey, my CPU is going crazy. Hey, my network is going up. There's always something to find. And you need to already evade all the malware and all the other tripwires that were set up to get onto that desktop. So writing Windows malware is much more difficult than writing an IoT malware. Some IoT malwares are just Python scripts. They just download it, leverage whatever Python is on the machine and just run it. So it's crazy that it's very unsophisticated because it comes on that layer which is on the public site. So there's no such thing as tricking user of downloading. That's more like the Android specific malware that is to steal credentials. For example, info stealers might be a good example of that. So these things will typically ask you to download something on your Android phone and execute it, or on your Windows. But IoT malware doesn't work like that. All they need is remote command execution in some way or another, a vulnerability around that. Once they get access, either by default passwords or a remote command execution, they can load their bot onto the device, execute it. Nobody ever knows.
Pascal, I got to ask you two topics which we haven't covered. I'm amazed we haven't really got into it yet. APIs and AI. AI is obviously all the rage. Technologies like these, it sounds like APIs are a nightmare as well, because people can just get direct access to very important data. And AI, it seems like attackers have the advantage with AI. But perhaps you can talk about that. You know, it's easy for me to say these things, but like, what are you seeing?
Yeah, so let's start with APIs.
Okay.
APIs are hard to secure because in the case of, for example, a website, you can verify if it's a human on the other side. An API, however, it's machine to machine, so you cannot verify interactivity or click on this or do a CAPTCHA or whatever. You cannot do that. So APIs are not that easy to secure. Another problem with APIs is that not everybody gets full control of their APIs, meaning that sometimes they have a developer team or a team that was contracted that wrote an API to support your application and put it somewhere in the cloud. And they're still testing and developing it, but they put it out in the cloud and they're not using the production database, but they just use a copy of it. However, that copy contains the sensitive data of people. It's only a matter of time before that API has been found. Another problem is zombie APIs. So APIs that are forgotten or legacy, let's call them legacy APIs instead of zombie APIs. Some APIs are still out there because there is one or two big customers that are still using them. However, those legacy APIs are legacy for a reason, because they didn't have the same security controls. They were not using the latest version of the compilers that were compiling the applications. They don't have all the authentication and all the other new features that the new services have. However, they're still online wide to support this one or two customers. Well, yeah, those legacy APIs are the first ones to be attacked and to be uncovered. Now, in some cases, the security team is not even aware of certain APIs that are being developed or that being mounted for development. So if they're not aware, they cannot put all the security protocols and all the security controls that they would like to put on APIs. They cannot put them in place. So biggest problem is actually, and that's what I said in the beginning, is that threat surface. Because we start to see more and more often that people are starting to build applications, but we don't build monolithic applications anymore. We learned that in the mainframe time it was not a good idea for flexibility. So when you started doing agile, we started to cut that in all smaller pieces. And those smaller pieces now start to be outside of the company, because sometimes why would I write a payment provider and payment checking program if I can use Stripe or something else that's already out there?
Yep.
So many applications now consist of third-party APIs that are being connected to them. And those third-party APIs, and that's where supply chain attacks come in, when a third-party API might not have all the security controls in place, or even when they have all the security controls in place. If you are against one of the nation states where you have very sophisticated attackers that found a 0-day vulnerability that got into their server, infected them, and then through that API that you're using, all your users' data is being leaked. Well, this is something that can happen if you have very good attackers there, and it happened not so long ago. Remember how much was it? $1.5 billion that was stolen from the crypto provider.
Yep.
Well, it was through the payment wallet that it happened, right? So it was a third party. It was like a supply chain attack.
That's a great example. I like that.
So that is the API side. API are always difficult to secure because most of the time we forget about them. We don't see them. They're used in the backend, and there's so many of them. And that's something that we see also happening in the internet, is that our applications are becoming a fully interconnected mesh. Now bring down one of those APIs and the whole application falls down again. So the weakest link. One of those APIs gets compromised. All the applications that use that API also get compromised. So it's hard to keep track of that. There are ways to keep track of it, of course, but you have to know that the API exists, and then it only becomes more complex for organizations to keep track of everything, right?
And attacks are increasing, right?
Yeah, and that brings me to the AI side of things, because it's not going to get better. If you look at the AI side, so what I'm looking at the most is trying to understand how the bad guys are leveraging, or how they can leverage AI.
Yeah.
And AI, the big boom came with the Gen AI. So I'm mostly talking about the LLM models and about the transformer models, also the pre-trained models, which are ChatGPT, for example. Now, when you go to ChatGPT and you ask ChatGPT, hey, write me a DDoS script, he will tell you, hey, for ethical reasons, I cannot, blah, blah, blah. Yeah, there are some prompt evasions. So you can put in like a special command, like a very special string, and then it will become more looser, and then you can ask it. But it's only a matter of time before somebody finds out that you're using that and puts in another guardrail. We call that guardrails to keep them ethical. Now, there's also something like Hugging Face. I don't know if you ever...
Yep.
Oh, yeah, you were in Hugging Face because you used LM Studio, right?
Yep.
I saw it actually from your video, and I think I learned it there, LM Studio. I don't know if I learned it from you. I think so.
That's great.
On Hugging Face, you can download those models, those open models, and you can use them locally. So offline. With those open models, and you also showed that in your video, there's a model called Dolphin.
Yep.
No guardrails. You can ask it anything. It will do anything if it's within its capabilities.
Yep.
Now, one of the bigger problems with those local models are that either you needed a big data center to run it, or they were not that performant. Now, there's one disruptor that came earlier this year, which is DeepSeek.
Yep.
So DeepSeek, I was not so much impressed by their performance because, the performance is like, it's like come and go, Now you're the best, and then tomorrow there's somebody else, and then tomorrow there's somebody else. The innovation that DeepSeek and the disruption that DeepSeek brought is to have acceptable performance, but with low requirements on the compute part, which means that it becomes a very interesting model to use offline. Another thing that DeepSeek, the team of DeepSeek added, was showing how you can cost effectively distill new models from bigger models and make them very efficient. Distilling and fine-tuning your own models. So that's where now AI comes in, where you can use it offline. Now, if you can use it offline, you can strip out all the guardrails, and by distilling it and fine-tuning it, you can fine-tune it, for example, based on a database of underground chats. You can use malware troves, source code of malware, put it in there. And then you can start selling it as a service. That's what Fraud GPT and Warden GPT did. Warden GPT started out, was a Portuguese student. They started out as a grey hat project, but it became so big that they then pulled the plug. I think it was August of last year that they pulled the plug on this program. But they were selling services on the underground where you get access to a Chat GPT variant where you could ask it to write evasive malware. Others are providing it to write deepfakes, for example. You know that deepfakes are easy to make now, and that's where the most of the risk comes from, is the automating phishing, automating deepfakes. So offline models is a very important part of being able to perform those attacks. Now, what does happen with the threat landscape if you look at those models? What is the impact of Gen AI on the threat landscape? When we didn't have Gen AI before, when you're a new hacker and you come into the space, how do you get in? Typically, they are gamers. They're already in some communities, online communities on Discord and talking and chatting with friends. And then they want to get an edge, so they go after cheaters. And then they stumble into a underground forum where the real hackers understand, oh, there's money to be made here. So they stumble into there. But in the beginning, when they want to learn, they don't know how to program. So they ask a question. But those are very toxic environments. They get insulted all the way for everything possible. Script Kiddie is like the nicest name that you can give them, because they get insulted everywhere. So it's very toxic, very harsh to get through. Now imagine that you have a personal assistant sitting next to you, which is either an online model that you pay $20 or $50 to get access to help you in writing malware, or just a Chat GPT even. And there's already scripts online to perform DDoS attacks. You just search on GitHub DDoS, you will find many. Search for Mega Medusa, for example, HTTP2 attacks. You want to do HTTP2 attacks, search for Mega Medusa. It's there. It's obfuscated. Well, ask ChatGPT or ask your offline model, hey, how can you deobfuscate it? It's rather easy. How can you improve it? And as you know, those models, they are not always that good at coding. So they are not experts, but they are better than a starter, right?
Yep, exactly.
I don't know if you tried it, David, but if you ask it to write a Python script, you try to run it, it's like, it doesn't work. Well, you go back to the chat and say, hey, it didn't work, and give me, oh, sorry. My excuses. And they are friendly. They're not toxic, right? They are patient. They have many cycles for you. They're always there. So those script kiddies now, and that's where I made a graph where before you had many script kiddies, and then as you go more sophisticated, you had less and less actors, and the most sophisticated ones, there's not so many of them. That shifted. So that point where you had the most now becomes like a bell curve, because everyone who steps in and can leverage a chatbot can get to a certain level that he can download an existing script, add new exploits, for example, and start leveraging this to perform attacks. So that's current day. Now, there's another technology in AI, which is called AI agents. Agents allow you to interact with the environment and in the backend use an LLM to reason. And also you can have systems of agents where one agent is coordinating another agent and even checking the results and so on. Now, some researchers last year found out that it was possible with a single agent to, based on coordinated vulnerability disclosures, so a disclosure description, just based on that CVE description, to build an exploit, to have it build an exploit. It wasn't possible with ChatGPT 3.5, but they found, so they first tested in the paper, and there's a paper out there. In that paper, you can see that ChatGPT 3.5 was 0 success. ChatGPT 4, 80% success. Now, GPT-4 is already a while ago. That was before the good reasoning models that we are promised now. So now we're already a step much further. Now, most of those vulnerabilities were also open source, because the model also had access to the source code, so can take the source code into account and so on. So it can find that vulnerability. Now, imagine, and that's something that I'm scared of for the next couple of months, most probably, if not already being used, is that whenever there's a disclosure of vulnerability, especially in open source products, nowadays, when the vulnerability comes out, before you see exploits in the wild, it takes a while. It takes like 24, 48 hours before you see the first exploits being used on the 1 day vulnerabilities. It does take somebody, most of the time, a white hat going to GitHub and posting a POC, and then the bad guys finding the POC and then leveraging them. Because they're not that smart, most of them who are going after the low-hanging fruit. Those are not the nation states. Those are like the guys who go after the low-hanging fruit. Now, it was 48 hours. Now, imagine that you have an agent that can download that description and build a proof of concept. It doesn't have to be perfect. As an attacker, you never have to be perfect. You can try 100 times. If you succeed one time and you fail 100 times, it doesn't matter. You're succeeded because that one time you succeeded. If you're in the defense side, you better get your stuff together, because if you fail one time, you're a failure. Might cost you your job. Out of maybe you did 100 successful, but this one time you failed, and that's a disaster, right? So now imagine that you have many actors running that and starting to doing that, and you have that whole scale. There will always be someone who finds that exploit somewhere. So what we see now is that when a new vulnerability is disclosed and you need to install an update, that window that you had, like 48 hours to patch it, which was already very strict for many organizations. I do remember when I was working in production environment, before you did an update, you had to pass 3 different committees. You had to sign off 3 different people, and it took like 6 months to get that update out there. And also, you can say automatic updates, but I don't want to say it too loud, but CrowdStrike, remember?
Exactly.
So things can happen. So people are not that 100% sure at this moment to allow automatic updates. But now we're looking at, instead of 48 hours before first exploits in the wild, that they might be completely automated and might come in minutes. And that's where I think that we need to look at AI as also a tool for our defense. So fighting AI with AI. Now, I don't want to scare people. In the 25 years that I was in this business and in security, it has always been the same game. It's always been a technology race between the good guys and the bad guys. We've always seen threats evolve. We have always seen us adapt to stop those threats. And now it just happens to be AI. And it's a big disruptor. Yeah, it's a rather big one. But you already feel that in your life because everything becomes AI. You cannot buy a toaster anymore without AI inside it, right?
Exactly.
Which was like 5 years ago, it was connected. Before, my toaster was just running on power and nothing else. You just put in the bread, that's it. But now, 5 years ago, my toaster had to be connected, or at least have a Bluetooth or Wi-Fi or connected directly to the cloud. Now your toaster has to be connected and have AI in it, or be backed by AI in the cloud, because you never know if your bread is not toasted ideally. So with this AI now, we are at the advent of something big, but I'm not scared, because I know that we have been in front of other challenges, and we will overcome that challenge as well. And we just will have to fight automation with automation. So AI on one end, you have those offline models, perfect for building underground services, where script kiddies all of a sudden become more seasoned hackers. So the sophistication on average of attacks will go up. I don't see the absolute sophistication become more sophisticated. I don't think that an AI will outperform a human hacker today. Maybe in the future, but not today. On the other side, you have the whole automation aspect with agents. And that's something very powerful. And we already use agents to automate parts of our life and parts of our tasks. Well, attackers will do the same. They will automate parts of it. So you will see that they now are able to cast a wider net, do more attacks. And that's where also you start to feel that there are more attacks. And actually, the number of attempts at vulnerabilities is up significantly in the last year. That might be related to it.
Yeah, it's interesting. I mean, I wanted to ask you, like, okay, how do I protect my business against DDoS? How do I protect myself against all of this stuff?
Protecting part of it is not so when you look at protecting yourself, and all the DDoS attacks that I have been mentioning, this HTTP2, the web DDoS attacks, the more difficult attacks that look like real attacks by no-name 05716, where they actually model the request to be a legitimate request, there's all solutions for that. So, but there's 2 big parts on the DDoS side. So you have network DDoS, which is more about volumetric attacks, and especially behavioral on those attacks, like you said, the SYN attacks, for example. And how can you detect SYN attacks? It's actually, how can you make sure that it's a SYN attack and not like a a crowd flash, for example, because you can have like somebody in marketing did a promotion and all of a sudden you have like hundreds of thousands of people connecting in because they only have 10 minutes to get the first ticket.
Yeah, exactly.
You don't want to see that as a DDoS attack and block everything, right?
Yep. Yep.
So what we are using, for example, is behavioral rate invariant parameters. So if you look at SYN attacks, TCP is a certain protocol. You have SYN, SYNAC, ACK. Now, if you take the distribution of SYNs and ACKs, so SYN, SYNAC, and ACK, there's a certain distribution. If you see a whole lot of SYNs, but the SYNACs are not following, something is wrong. So those are attacks. So those you can block. So on the network level, you have to protect yourself with network and volumetric. So also if you see certain volume go too high, then we need to start blocking them. And again, behavioral detection can help there to find out which IPs in the backend are most attacked and which are not. That's the network part. Then you have the web DDoS attack on the application level. Those need another treatment. You might say, yeah, you can do it in the web application firewall, but web application firewall is too expensive in compute to check all the different transactions that are coming in. So we are using a special gateway for this that we call the web DDoS protection that can find changes in the parameters, because one of the things about those web DDoS attacks is that they use randomization. They randomize the header variables. They randomize the user agent, for example. And that's not something that regular users are doing. So typically when you look at the distribution of user agents that comes to your website, and you would make statistics on that, and then you see an attacker coming in who's leveraging 100 different user agents, you see that something is wrong with those IP addresses. So then you can easily block them. The most important thing is to block them, to block the illegal ones without blocking the legitimate requests. Yeah. Because once you start blocking the legitimate requests, well, the DDoS is actually a success. So that's the whole thing. You might say, yeah, we're going to use throttling, but throttling is not the solution either. Whether it is for DNS or for web requests, if you have 98% illegitimate packets and you have 2% legitimate packets, if you throttle them, if you slow them down, how many percent illegal packets will you have?
Exactly.
98%. So it doesn't solve the problem, right? It only makes a smaller amount of legal. So the 2% legal will be smaller because you throttled them. So instead of 10, it might be 2 that get access. So for protection, you need good technology and a good protection provider. Typically for the volumetric and for the web DDoS attacks, it's very hard to host it yourself. We're talking about hundreds of millions of requests per second. In the volumetric, talk about 2.5, 3. I think that now 2.5 to 3 terabit per second is the record. So yeah, once you get to 3 terabit per second, it's also be careful about the sneaky ones, because we talked already about low and slow. And remember that I said that sometimes those HTTP requests come in to consume your resources. Now, imagine you're in the cloud, you have an elastic cloud. And whenever there's too much requests coming in, your CPU, there will be a CPU added because you are elastic. When that happens, when you add a CPU, it will stay there and then it has a cooldown time. Now, there is some attackers, I saw some attacks that were doing that actually came in, they start requests, so DDoS like with requests per second, making it go up until the server adds a CPU, and then the attack goes away for 10, 15 minutes, because that's the cooldown period before the CPU is again falls down to 1 CPU instead of 2 CPUs, and then the attack starts again. So that's actually trying to exhaust the economy of the application just by sending those small attacks that are almost invisible to see, because they're so short and so small, but they cause you always to move up into the next gear. And that's something that people in the cloud need to be careful. And there were some Reddit threads about that as well, where it happened like, when you don't have DDoS protection, your website is hosted in the cloud. Yes, your website can handle probably hundreds of thousands of connections per second, and probably can handle a terabit per second because the cloud is very capable. But look at your contract.
Yeah, exactly. Yep.
You are paying for a certain amount of terabytes. So It can be at the end of the month that you get a shock because your invoice might be like maybe, and I'm not talking about 10 times, maybe 100, 1,000 times as much as you used to, because of all the traffic that came into your website. And that was illegal traffic. So it's important to have a DDoS there to protect yourself against that. It's very unfortunate, but as we said at the start of our discussion, the internet is a best effort network that was created for everybody to get access. It's very democratic. But at the same time, we decided to put our multi-billion-dollar business on top of there. And it's the same network. So everybody still has access. Good guys and bad guys. Just have to live with it.
So Pascal, you work for Radware. Is that correct?
Yeah, that's correct.
So what does Radware actually do?
So Radware is a provider of application protection, application availability. So we have DDoS protection against network attacks, against the volumetric attacks that I talked about, against the application level attacks. And we also provide application protection on the level of web application firewalling, which can be either on-prem or in the cloud, or both in the hybrid that we can use. And the web protection also has a bot manager part of it. So because, if you want to protect a web application, there's not only the application itself that you need to protect against exploits and 0 days that are trying to compromise your application, but at the same time, you also need to manage bots. So we also have the bot management aspect on top of that. And Radware originally comes from load balancing. So we still have the load balancing aspect as well. So everything that covers application deployment and application availability, application security. And when I say application, I mean published on the internet. That's the business of Radware.
You've said that DeepSeek was great because it allows us to run a model offline and have a lot of power. But you mentioned Hugging Face as well. I hear the problems, however, getting these models. There's issues perhaps downloading these. Have you got some thoughts about that?
Yeah. So most of the time when people talk about issues or when people have reservations of using an online AI model like DeepSeek, we always think about the privacy because there's a Chinese government behind it. It's not secured because they rushed their service out and their database was leaking.
Yep.
But think about local models. Local models can also be an issue.
Yep.
You are going to a repository and you're downloading a model that has been created by somebody else.
Yep.
Have you vetted?
Exactly.
Even with distilled models, have you vetted which data it was trained on? Imagine somebody training a model on vulnerable code, only vulnerable code. Now, many organizations nowadays are using or want to use AI in coding to help in coding. Now, of course, Samsung was the first to find out that it was not a good idea to use a online AI because all of a sudden somebody by accident put in the wrong prompt and got some proprietary code from Samsung applications as an answer in ChatGPT. So, and that was actually an article that was out there. So that really happened. Imagine everybody wants to go private and local. So you download a model and you use that for coding. That model might be created by an opposing government or another regime that was built and trained on vulnerable code so that your applications become more vulnerable, so that actually you have more vulnerability, so you're weaker and they can leverage that advantage later on. That's called poisoning. So you can poison those models. So we need to be careful about the models that we download. We need to vet them, one, but more probably and more importantly, I would say go to the extent of leveraging the same technology that DeepSeek put out there and that we see from others and all the articles that are written about it to distill your own model and train your own model, customize it based on your code. It will actually perform much better. And that's the thing that I like about the AI nowadays, because it's not the first time that we see AI coming up. AI has been through many winters and summers. AI is older than me. Imagine that.
Yep.
So what's so special about this AI, and it says it in the name, it's pre-trained. Yeah. So the GPT, the pre-trained models. So somebody already invested the whole big data center to train that brain. Now you can take that brain with all its content that comes with it and leverage it like that, but it's not customized for your content. Yeah, you can use RAG, you can use in context information to customize it a little bit on real-time data. But I think that it's more important, just use that brain, use the capabilities of that model, and around it, put the layer of your own information by fine-tuning. Distill your own model, fine-tune it. It will take you maybe one engineer, but then at least you will be sure about the content that's in there. Because poisoning is a real thing. There was very recently, it was an article where there was researchers, and they find that they could change the in-memory context of a chatbot in such a way that when people ask questions, they got the wrong information. And that was with chatbots. Chatbots use an in-memory cache for the context. So what they were able to do was stage certain commands in there so that people ask, for example, oh, give me a suggestion for a prescription, or not a prescription, but give me a suggestion for some pills for coughing. And it might give you pills against something totally different because they pre-staged and they poisoned that memory that was out there. And they did it in live chatbots. So poisoning is a thing to be aware of and to start looking out for.
I mean, it's a risk, right? Because like you said with the Samsung example, a lot of companies want to put LLMs in their companies, leverage this, and then they want to use it on their private data as well. And I mean, if, like you said, if someone downloads an AI, uses it locally, and that thing's poisoned, then an attacker could like send a special command or something and extract your personal data or something, right?
Oh yeah, AIs are the worst at keeping secrets.
Yeah.
Look at it like that. Never give your secrets to an AI. Whether it is your personal keys or personal information, don't do it. Because most of those models are learning from whatever that you are giving them as a prompt or as information. And yeah, Samsung find out the hard way that it is like that.
Yeah, like
don't
you mentioned.
mistake. That's where the offline models come in. But there's also risks because those offline models are created by others. And actually on Hugging Face, there was already a supply chain attack. Like with all repositories, whether it's PyPy or whether it's the other repositories for open source, there will always be somebody who finds a way to get in and to do something malicious. So on Hugging Face, there was somebody who found a way to get in the pickle code, the pickle that serializes the model to download and then extract, to put some commands in there that executed malicious or downloaded malicious information or a malicious binary. So it already happened, but it can also be, you don't know where that model comes from, who trained it. It can be vulnerable code. It can give you instructions to do something really bad that you don't even know. So be careful with the models. They could be poisoned.
I just think it's another attack vector, right? It's another thing that companies have to really worry about.
It just comes on top of all the others that we already have to worry about. And it's a supply chain because it's a whole repository that's out there.
That's fantastic. You are on LinkedIn. Is it possible for people to connect to you there? What's a good way to,
perhaps? Absolutely. Yeah. I love people to get out there and ask me questions. I really like it when people ask me questions. As you can see, I like to talk.
No, I love it. I mean, what I love about what you've done is it's not just high level stuff. You've given us some nitty gritty, like in-depth stuff. And that's always the fun part, right? To actually understand. Yeah, the stories are great. So I really appreciate you sharing. Yeah, exactly. I mean, it's one thing to talk about HTTP in theory or whatever, but it's so much nicer to hear that this is actually what happened out there. Have you got any closing thoughts before you wrap up?
Well, pretty much what I said before. So this internet that as we started, we talked about the internet being democratic for everyone. Everybody gets access. It's a best effort network. We built a whole business out there on that network, but we need to be aware of the risks. Whenever we put something on that network, everybody can have access to it. It can be compromised. We can become part even of an attack. So you wouldn't be the first one that gets all of a sudden the authorities on your door that said your IP address attacked one of the biggest organizations or governments in your country, because that's exactly what attackers do. They will hide. And how do they hide? Well, maybe behind your vulnerable modem or firewall. So it's always important, even at the level of the consumer, to keep our devices secure because it's all connected together. If you have a big business and all of a sudden that big business gets attacked by 900,000 bots, those 900,000 bots come from consumer modems. So I would not say that security is only for the high-end enterprise. It's even for the consumer. It's important for all of us to be aware of the risks and to be aware that this internet, we're not alone on that internet. It's a public street. Everybody's out there.
Pascal, thanks so much for sharing. Really appreciate it.